Hello and welcome to the Digital Futures English Language Workshops introductory session. Today, it's really quite an extraordinary moment, I think, in the history of Digital Futures. We have been working intensely on setting up these workshops. I'd like to say something about the numbers that we're dealing with this particular year, which is quite extraordinary. Can we next slide, please? This year, we at present have 137 workshops. It may rise to over 140. And looking back over the humble origin, shall we say, of Digital Futures, back in 2011, when Philip Yuan and I initiated the project, we could hardly have imagined that it would have grown into the kind of extraordinary international platform that it has. With the pandemic, we launched over 80 online workshops. We went online, we went global. We had hosted over 80 workshops. We had 12,000 applications for that particular session. And then it subsequently grew to over 100 workshops last year. And this year, we are breaking new ground with over 130 workshops. What I think is extraordinary, though, is the fact that I am introducing this as the English language session for the English language workshops. Because what the most significant shift, especially over the last year, has been the introduction of different languages. We've opened up a whole series of different language channels. And this year, we're going to have sessions in English, as you can see on the left-hand side, English, Chinese, Turkish, Portuguese, Spanish, Greek, Arabic, Farsi, Korean, and Japanese. Extraordinary sort of lineup of different languages. And that's important. To be inclusive, we have to move beyond the limitations of only speaking English. And this has been, I think, to my mind, the most extraordinary thing that's happened in the past year. I want to thank the team, the core team, you know who you are, and also the other supporters, the managers all over the place who have been working intensely the last 2 or 3 weeks to really put this together. Also, the new website, in particular, I'm going to single out Mohammed Beju for setting up the new website, DigitalFutures.international. But to just pick out anyone is to leave out the others. It has been a team effort, an extraordinary team effort at that. I'm going to hand you over to Bavleen, who's going to say some further words by way of introduction. So welcome to Digital Futures 22 English Language Workshop Preview.
Thank you, Neil. Thank you, team. I think before we begin this extraordinary session, which Neil just mentioned, I think it's a good reminder to just take a look at the timeline that we have and the schedule that we have planned for the summers. This year we will be starting on 13th June till 24th of June will be doctoral consortium hosted by Tongji University and the PhD program at Tongji University. Followed by that would be the opening ceremony on 25th June and the CDRF conference called Hybrid Intelligence, again hosted by the conference hosted by Tongji University. On 26th June to 2nd of July is our workshops, which comprise of 10 languages and more than 130 workshops spread across a period of 1 week. The closing ceremony, which will also have the awards presented, will be on 3rd July, and ending with that would be the exhibition opening, both virtual and the physical exhibitions on 9th of July. And these are further some of the dates for your reference. And this is our 6th session, which is happening in the last 2 weeks. We've already had workshop previews in Spanish, Portuguese, Farsi, and Turkish, Chinese, which just got over just a few minutes back, and we had some really exciting lineup for these workshops as well. Do check out these workshop previews. Some of these also mention some English workshops, and today we will try to give you an overview of all the English language workshops, followed by our session. Afterwards, we also have Arabic and English workshops sessions today at 1 p.m. EDT, and tomorrow we have Korean. Watch out for the next 2 sessions. They are going to again have some really interesting workshops in AI, computational design, and multiple other themes. Again, as an introduction to the Japanese workshop, and as well as one of our first Japanese channel that we are setting up, will be hosted on 31st of May, Tuesday, 31st of May, 9 p.m. Japan time. This session will be again live streamed on YouTube, Bilibili channel, and the moderation will be done by Satoru Sugihara. You can find us, of course, on YouTube for those who are connected with us on YouTube, but we are always active on Twitter, Facebook, Telegram, WeChat, and Bilibili as well. Just for those curious students on wanting to know a little bit more about the application process, the followed by that, just select your workshop, apply for the workshop before 11th of June. This time we have extended extended a little bit to the applicants to be able to apply to up to 5 workshops, from which our instructors, which is also those that are connected over here today, would be selecting. And on 11th of June, workshop registration will close, and by 17th of June, all the selected participants will be notified. Now, heading back to the session for today, I would like to now invite Chao, who is joining from Tongji team, one of our colleagues here, and he would be starting to give a preview of what the English workshops look like in the next couple of minutes. Followed by that would be Ipsita Datta, and then Lamilla would be explaining a little bit more about all the workshops in English from the European time zone. So
thank you. But before we start, we just had a great session on Chinese workshops, and Philip also gave a lot of comments and overviews. Philip, would you like to say something at the beginning before we start our English sessions?
Okay, I think just a few remarks on the this year. I think the topic this year, One Planet, is extremely important based on the global situation. Not only we have the very special COVID situation, the war in the other side of the planet. So it's super important to be thinking on the technology. How should we address all these kind of workshops to set up some new motivation, new goals for the future? So I would like to show great thanks to all the participants, all the tutors for the workshops. I think we're looking forward to spend a special time with all of you. So the Chinese workshops, we have around 20 in the Asian and Pacific time zone, and we already set up some collaboration with Mike Xie from Australia and also from Singapore. I think there will be a great experience in the next 1 month. I'm looking forward to spend a great time with all of you. So, and next, I think we already start. So we would like to invite some other English. We have still 7 English workshop. We want to invite them to make an introduction. So, Chao, would you start?
Yes, okay. Just give a brief overview about the 7 workshops we organized for the Asia Pacific time zone. So we have 7 workshops. The first is by Zaha Code and Tongji, and the second one is a joint workshop by ICT Stuttgart and Tongji University. And we also have Kai-Ho Yu from University of Applied Art, Virginia, and also myself, Virginia, and Philip, we teach a workshop on inference for architecture. And the next one is Nari He from Virginia Tech. And then the next one is Nick Bao and Yanxin Maxie and the team from CSCEC. Jianenpeng and Qiu Wei. And the last one is Lou Tiantian from Harbin Institute of Technology. So we're going to introduce the 7 workshops one by one. But before that, unfortunately, the Zaha Code team, they cannot make it today. So I will just briefly introduce on behalf of them. Their theme is architecture for the metaverse. It's based on Patrick's recent theory on the metaverse. And they're also going to teach some technical design techniques based on Maya and Unreal 5. So you can just follow us on our website and to get more details about this workshop. It's going to be led by a really amazing team, including Patrick himself and Shajay and also other team members from Zaha Code. So that's the first workshop, and next one is ICD and Tongji team. They're going to teach a workshop on digital fabrication. So I will invite the team members from ICD Stuttgart and Chaihua. They're going to give a presentation on their teaching content. So I will stop my screen. Is ICT team here?
Yes, I can share my screen.
Yes, please.
So hello from Stuttgart, and welcome to the introduction of the partner workshop between Tongji and ICT Stuttgart called Agent-Based Modeling for Materialization-Informed Architectural Design. The workshop will be held in hybrid mode between a group of researchers from ICT Stuttgart, streamed online and in person at Tongji University. So yeah, from all the researchers who are not currently here, we're a group of 7 researchers, also a warm welcome and hello to this introduction. The workshop is based on 2 main pillars. One is the computational approach of agent-based modeling and simulation, where we use agent-based modeling to negotiate different structural and fabrication parameters. And the other one is the materialization approach, where we want to have a look at using robotically controlled bandsaw cutting to create freeform surfaces or larger shell structures. So just as a quick introduction, like what is agent-based modeling and simulation and what is an agent? Agent-based modeling and simulation is a relatively new approach in modeling complex nonlinear systems. So relatively new means around 40 years, like developed as a discipline in the 90s. And why complex nonlinear systems are quite interesting for us, because also buildings and the way building elements interact can actually be understood as complex nonlinear systems. And what makes agent-based modeling kind of special is that we model complex systems from the microscopic perspective, basically focusing on the individual element within a larger system, which in our case can be, for example, a building element. Now, just to give a brief overview in architecture, I think also from the titles I just saw on the previous slide or in the previous introduction, agent-based modeling is often used to model, for example, crowds or people in urban environments. We are focusing here on modeling building elements as agents. Just also to give a brief overview on work that was already done with this modeling approach is here, for example, the Landesgartenschau exhibition hall in 2014, where basically the self-organizing properties of agent-based models were used to basically communicate between structural requirements, but also fabrication constraints in order to have this self-organizing process here inform the final geometry of that shell. What is interesting about agent-based modeling in comparison also to, like, let's say, purely optimization-based approaches is the way that it allows for interaction. So for example, here we can have an agent-based model where we can basically readjust single node positions and then basically manipulate the way a system behaves while still looking at different kind of structural but also fabrication constraints. And now the plan for this workshop is that we want to extend like current applications that the ICD agent-based framework was used for. And we want to extend this with the specific constraints and also possibilities offered by robotic pencil cutting. And the fabrication process we look at in detail will basically look into free-form timber elements. So when working with timber, we're often used to only having, let's say, a simple curve or completely straight elements. Here we want to use the pencil cutting to create these complex and ruled surface elements, like you can see on the right, top right. And then we want to combine these elements to create free-form surfaces. So the strategy here is to convert an arbitrary given surface module into a single curved glulam plank by subdividing the surface into specific strips and stacking them in another direction. And then using this freely designed surface as an input, we can use an agent-based modeling approach to find an appropriate segmentation scheme that is compatible with the materialization process, cutting, stacking, gluing, and then connecting resulting modules to meet the given design model again. Since the curved glulam planks are easily factory produced, the robotic bandsaw can cut the plank into strips and reassemble them into double curved surfaces. This way of producing surfaces is highly material efficient and has better wood grain continuity within the timber elements than other fabrication processes, like, for example, CNC milling. While the computational part of agent-based modeling will be taught online from Stuttgart, the fabrication happens at Tongji University, where we can use the Gantry robot facility with all kinds of different end effectors to produce these really highly intricate timber structures. So here is an example of the fabrication facilities we can use. And then this is also another quick, let's say, preview of the space that we have available to really basically also materialize the previously designed structures online. And yeah, this is a rather large space where we have, I think, can clearly show the capabilities of the fabrication system, but also have enough space to explore what is possible with agent-based modeling. And as a brief overview, we plan to have a block of skill building tutorials in the beginning. So skill building based on the ICD ADM framework, and then start from there developing own designs and agent models with custom agent behaviors. During the workshop, we will have, or we plan to have some input lectures and hybrid design and development sessions where we look at individual designs and support in problem solving. So that was a quick intro from our side at the ICD Stuttgart, and we're looking forward to an interesting week in this hybrid workshop format. Thank you.
Thank you, David. I think it's a really interesting workshop integrating the agent-based modeling and fabrication. So next one, I would like to invite Kaiho Yu from University of Applied Arts. He will give his workshop named Behavior-Based Quad Fabrication. So Kaiho, please.
Thank you for the introduction. I'm from the University of Applied Arts, Vienna, Institute of Architecture, and I'm teaching a workshop titled Behavior-Based Crowd Fabrication. But I'm pretty sure compared with what Stuttgart ICD is doing, what our focus is much smaller or on something super specific. So what we are thinking is how to use simulation as a bridge to connect physical environment and digital environment to simulate the behavior of crowd robots. So in the past, we have been doing experiments, as you can see in this video, on factory robots such as the Kiva from Amazon to understand the behavior of robots, their path, and how to realize the goals. And in order to understand like the robots, we have to go back to the autonomous driving cars and think about how to utilize this kind of technology, the path planning technology, the SLAM technology, into how we would fabricate. But in this case, as an early stage, I would more call this assembly. As you can see in here, the students would start to experiment with different path planning techniques for crowd robots to navigate and also assembly in the space. So in the past, we have been doing a lot of design to think about how robots are integrated in the building space. So this one is from the studio I taught with Greg Lin and Martin Nowak in how the robots can be integrated into office space and how they interact with human beings. So in the past, on the platform of DigitalFUTURES, we investigated like prototyping robots, algorithm and research, crowd behavior, and also investigation on animal behavior from the nature. And for this year, we're looking at how to start to think about fabrication, not by giving a certain path, so different from a top-down control, like how you would fabricate with 3D printing, but more like a goal-oriented construction, like Lego assembly in a scenario of crowd movement. We are hoping new ideas of intelligence might emerge, and that is what we are interested in this workshop. So as machine behavior cannot be fully understood without the integrated study of algorithms and the social environments in which robots operate, in this workshop, we invite students not to be designers, but operators, meaning we're going to give them certain rules and guidance, and they're going to figure out, how to build the most in a certain amount of time. So at the end, what we're going to evaluate is who builds the most. We're going to rank the students, because they are like the operators playing the game. And we're going to use Unity and behavior tree as a tool in this workshop. So as I said, the main algorithm we are using is the A-star algorithm for path planning and goal searching. The students will need to control the robots, not by joysticks, but by telling them, by defining their behavior tree and testing with swarm intelligence, as robots will not be scripted individually, but categorically. Students will engage with the game and design throughout the gaming process during the whole week. And then the evaluation is the fabricated area with a certain amount of time. That's the whole introduction. Thank you everyone for listening, and hope we have a nice summer together and a fun workshop. Thanks.
Thank you, Kaiho. Next one, I'd like to invite my colleague Virginia Melnick to introduce our workshop with Philip together. The name is Inflatable Architecture. So Virginia, please take a stage.
Yep, can you see my shared screen now?
Yes, okay.
All right, sorry, this is the end of the presentation. Hi, I'm Virginia Melnick, and I'll be teaching a workshop with Chao Yan and Philip Yuan. Our workshop is titled Inflatable Architecture, Animating Environment with Pneumatic Structures. And we are taking inspiration from a lot of pneumatic structures that are large scale and aggregated types of inflatables. You can see some historic examples here. And as well, these kind of geometries, which are structurally sound as they are pressurized and inflated to hold their shape. For these practices in the workshop, we are going to be working with a series of experiments using inflated and tensile structural elements to design architectural objects which can interact with humans. So we're looking for those elements of transformation and change, inflation and deflation actions. The workshop will be given with lectures, both about history of inflatable architecture, as well as contemporary practices and different types of inflatables that are in existence. We'll offer a series of software tutorials using Rhino and Grasshopper and Maya to simulate pneumatic formation and inflation and deflation and processes to help design and form these geometries. And we will also collaborate with a local factory in Shanghai to make prototyping and physical samples to understand the material behavior and the associated transformability of these geometries. The final outcome will be some computational design and also physical samples. So we'll be working both digitally and physically in this workshop. So keywords is obviously we're interested in inflatable architecture that's transformable structures, aerodynamic simulation, interactive design, and tensile material behavior. The required skills, we're going to look for students who have some knowledge of Rhino and Grasshopper, but you don't need to be very advanced for this workshop, just basic skills are necessary. Some basic understanding of Maya is also suggested, and ability to use Adobe software for representation means, so Illustrator, Premiere, and After Effects, since we are looking at moving elements in the workshop. So those are our softwares, and you can see some images examples. The schedule for our workshop will be June 26th to July 2nd. And you can see we will go over some lectures, some software tutorials, and then we will also have design reviews where students will have the opportunity to share their work and get feedback. And then we will also have some trips to the factory to collaborate on physical elements, hopefully, and continue to share our review. And then it will end with a final presentation on July 2nd. And just a little bit about Chao Yan, me, and Philip. Chao is a professor at Tongji University. I'm a PhD student and the Digital Futures International PhD program at Tongji University. And of course, Philip doesn't need any introduction, but is the Associate Dean and Professor at Tongji University. And thank you for listening to our workshop, and we hope you join us and register. Pass it on to the next person.
Thank you, Virginia. I hope you can find this workshop interesting. So our next speaker is Nero He from Virginia Tech, and his workshop is Digital Construction Land of Monsters. So Nero, please.
Hi, hello everyone. My name is Nero He, and my topic. Well, first of all, thank you for inviting me to host such an amazing workshop over here. Can't wait to have more students engage in this beautiful conversation with me. The title of the workshop is Digital Construction Land of Monsters. A brief introduction myself is I'm a visiting professor of Virginia Tech, and I'm a founder of my own design architecture practice located in Beijing and also Los Angeles on the title of He and Athon. And the beginning of this conversation started with me thinking about how we are using softwares and how software has been developed from the early ages, has been 20-something years, since the popular software lended to the industry of architecture. And then I was really astonished by the question being asked from a museum curator when he described a beautiful installation called Colloquial of Melville. And the question he asked is, what do we do with machines? Do we let the machine predetermine everything for us, make the calculation in advance, and be the smartest AI in the cloud that tells us what we want to see every moment in the world? Or we want the machine to produce something playful, sometimes random and unexpected, and something special. I think I align myself with the second part of the agenda more. So I myself is very interested in these ideas of creating quasi-autonomous workflow. And quasi is when designers are in collaboration with the computer and be the curator of pick and choose which operations or which prototypes are better created by both the designer and computer. None of the agent is overriding another. And autonomous is trying to optimize and automate the limitless possibilities for us to explore. So the digital construction conversation began with the class, me and senior faculty at SciArc, Peter Testa, taught a seminar together called Textile Hacking Lab. Basically, the idea is we very much simulate how textiles are working digitally and consider them as real as they could be. So we digitally fabricate the textiles and ask students to create more textiles in a digital world with a certain amount of constraint and be surprised by the outcome produced by the computer. So we, in the end, we got this amazing feedback from the students, amazing work, and conversation about computer hardware and software limitations becomes a very real thing. And how to fabricate them? Are we gonna create different machines in real life for this type of fabrication? Or what kind of material we're using are very much in line with the conversation. So with this idea in mind, I take the idea and kind of moving away from the micro lens to a macro lens and create this class called Pile of Things, Visual Construction, Pile of Things in Virginia Tech, which been taught last semester. And we use similar construct and consider material as real as we could in digital realm, and thinking about how architecture components can be re-see and reconfigure and reconstruct by not only simulation, but new type of workflow. So with that being said, the class I wanted to introduce or here in the workshop is named on the title of Land of Monsters, which we not only play with the simulation and see the new configuration of upcycled and recycled digital physical materials, but also start to think about how they could join together, how we could bring them to real world. Are we going to create new joins? How we fight against the standardization of mass-produced joineries and materials. And here's a little video my students made for the class. So yeah, the keywords of this class is digital, waste, upcycle, quasi-autonomous. Required skills are basic random model skills and simple render and animation experience. So we're going to use Rhino and Cinema 4D as the major software to engage with simulation and construction. Thank you very much.
Thank you, Nero. It's very interesting workshop questioning our traditional way of using software. Okay, so next speaker, I would like to invite Nick Bao, who is also a team member of DigitalFUTURES and also an old friend. Hello, Nick. Please take the stage.
Hello. Can you see my screen?
Yes.
Yep. Okay. Hello, everyone. Yeah, thanks again, Professor Philip Yuan and Yan Chao to invite us again for the running the Digital Future 2022. So this year our Digital Future workshop name is Reforming. So it's Reforming Architecture from Nature Morphologics. So it's the teachers of myself and Dr. Xin Yan, Professor Mike Xie, and Dr. Qiu Wei and Dr. Jianan Peng. So we are from MIT University, and Xin Yan is from Tsinghua University. Now is part-time teaching at MIT, and the Dr. Qiu and Dr. Peng from CSC EC. So we also have a teaching assistant. They are respectively from MIT, USTS, CUMT. So they are previously our Digital Futures excellent students from the past years. Also, this time we will invite Amoeba team, the Amoeba developers, Zhou Qiang, Shen Wei, and Yao Yuan. So at the beginning, I just want to show most the image I showed in my previous presentation, like the simulation of the apple shape optimization by Professor Mike Xie. So later, he developed the BSO method. Also, we used this method to attend some competition and win the first prize. Also, a lot of the architects using the similar the modified BSO method to design some buildings, like Arita Asuzaki. So Professor Mike Shear's team developed this Amoeba software to help the designer and architect to use the BESO method more conveniently. So also we in the past few years I used the similar the software. I use the modified BESO and Amoeba to create some interesting projects. So it's including part of my PhD research project and also one project doing with Professor Philip Yuan's team, the concrete printing project. So just to let everyone to review to have a look at our previous work. So we start our workshop from 2019 and the X-Form. It's in-person teaching, so we are all teaching in Tongji University. It's very good memory. Then this is the best the project from the students. It's a Chinese heritage design using the typology optimization method, and also we print the pavilion legs from RMIT Architecture Robotic Lab, and also bring to the Tongji University and work with students, assemble in the campus. So this is a final photo and a group of our student photos. Then the 2020, everything is moved online, and we are running the bioform based on typology optimization workshop. So we also ask all the students working online, we change our teaching mode and make every project on the panel and create using the hologram Ed Studio to create online virtual exhibition space, which is quite interesting. So we're gonna also create a new virtual exhibition space this year. So the most successful project from 2020 is this Eiffel Tower 4.0. So we also help them to 3D printing it. So last year, we are quite lucky can work with the China Construction Science and Technology. So this year we also work with them again because we cannot travel back to China last year. So we run the workshop online, and Dr. Cho and Dr. Pan run the in-person teaching and assemble project on site. So this is most of the students' work from the workshop. They are from all over the world, and most of them from China. And they design the different projects using the BESO and Amoeba. So you can see they have quite a creative ideas to design different products, including the stamps, also the Chinese characters, using the BESO method to creating different items. And also they design the bridge, then make the final render, and also design the sand gallery using the wing load to create the envelope of the gallery space. Also they designed this the big Ferris wing, which is also a very interesting project. We also put it on the cover of our workshop on the website. Later, we're also using the 3D printing. So Amoeba company is 3D printing this project for them. Also, the two students, they are also our teaching assistant this year. They did another Chinese heritage building last year. They also published this project in the related conference. Also, the two students from MIT designed another heritage, which is quite impressive. Some students also designed the pavilion and designed another pavilion space. Also, the design the staircase. So last year, we also using the wing load and the environment elements, and to using the wing load as a main effect to influence the design. We designed the wall, which called intelligent form. This this project also win multiple awards in the past year. And we also build it using the 3D printing technology and spray the UHPC concrete. And we designed the formwork, and 3D printing the formwork in China. And later we spray the concrete on the formwork and demold it and move it to the Tongji campus and assemble on site. So this is the final outcome. Yeah, we're quite lucky. Last year we can build it. So this year we will involve more the CFD ideas and BSO Amoeba, mix these two different techniques to create a new projects. Our students to so this project Taihu Stone are working with Fen Zuoyuan, one of our students, and also publish another conference paper. So we're gonna develop this skill into this workshop to test it. So we're quite lucky have the two partner, Amoeba and Chinese Construction Science Technology. So the workshop gonna be in two parts. One is online, another is in person. So because some reason, so we cannot go back China and especially Shanghai. So we're gonna run the in-person workshop in Amoeba company. So the student in China, they can travel to they can travel to Nanjing, so they can go to the Amoeba office to attend the class. And later we're gonna apply the created project to the real architecture, and also gonna build it within 1 year. So welcome to joining us. So our pictures is here, and you can click it and view and see more information. And welcome everyone.
Okay, thank you, Nick. Looking forward to see some new fabrication projects from your workshop today, this year. Okay, so the last workshop from my the session I'm chairing is Lou Tiantian from Harbin Institute of Technology. Sky, so please.
Yeah, thank you very much. Let me share my screen. Okay, good evening, everybody. Thank you very much for the invitation again from Digital Future. This year is going to be another fun, exciting round of workshops looking at all the contents being presented. So for me right now, this year I'm going to have a workshop titled Spatial Narration Interactive Content Design in Mixed Reality. So a little bit of my background, I'm a Singaporean now working in China, in Shenzhen. So my main research is bottom-up human-centered architectural design concept using VR, BIM, and all this interactive platform. So my idea, this workshop is to actually look at the interactive interaction between the physical and the virtual. So right now we are having all this trend of going into metaverse and going into all this virtual environment and content. So what we are trying to look at is to see how we actually interact with this, and not just going into the virtual world like totally, but actually looking at how this can be integrated with the physical environment and see how this integration can be based on the various sensors or gadgets. So for this workshop, we actually look at the connection between the Arduino and HoloLens because we really want the content to be actually superimposed with the real environment. And then, to actually interact with the real environment, we have to have a lot of all these sensors and feedback loops of, so we use Arduino to have this, to kind of act as a placeholder for, something better, but, this is cheaper as to do for a workshop. And then of course we need to design the virtual content. So this could be done in Unity, and they can be used to actually create a lot of interaction, interactive content. So I started off with this research from an architectural point of view, where I actually look at the bottom-up design to actually involve non-architectural, non-professional people to be involved in the whole design process. So in the meantime, I actually find that there is kind of a gap between the user needs and the technology being provided. So right now, what we want to do is to see how we can actually have the people to be included into the whole design process, and see how this can be expanded towards the other field. And so what we are trying to do is to bridge the gap between the human and the physical object, how we actually interact with it, and also in the meantime to see how we, this human computer interaction has been around for this research has been around for many years, but to how to actually link it with the human and virtual environment. And then of course we have all this human and human interaction, and we also have to see how this interaction can be, how would it affect the human-human interaction within the virtual environment. So we are, looking at how these three types of objects can be interrelated. So since last year, from Digital Future, we actually start to look at how this technology can be can help the interaction between the physical and the virtual environment. So we actually did a little bit of tests, and during the workshop we have people to try and do all these physical objects and design models and create virtual contents and see the connection between the two. So some of the example being shown. And right now we are also looking at how this can be involved, how this can be used in the context of tourism and in China, in much more of a, not really tourism, but in a sense called cultural heritage. And then we are also having this topic called rural revitalization in China. So we are trying to see how this technology can be used to help people to get better involvement of the content. And right now is we are in a COVID situation, but maybe hopefully ending soon. But in the meantime, we are still we are hoping to use this technology to engage with people in a much more remote manner. So this year, Digital Future, we also want to see how we can actually promote and use this content and do the workshop internationally and see how we can actually connect with the people around the world. So a little bit a short video to show what it is all about. So this is a place in the hometown of my master student. So what he did is actually create these little small gadgets and connect it with the real environment. And he kind of abstracted out into layers of roads and placeholder of the architecture, iconic architecture. And then what he actually do is to have all these little physical cards. So it's just a very small experiment to start off some try. So when you move the cards and you move around, you can actually see how the space can be connected with the real environment, and it kind of superimposed to so the user can actually compare it with the real environment. But this is only the interaction bit for the physical part, and actually react to the virtual content. So during the workshop, we are also going to connect it with where you actually interact with the virtual content. It actually reacts to the physical world. So to kind of summarize the kind of interaction we are working on, we have all this eye tracking, brain wave, and motion captures, and we have using the 5 sensors to connect with the people. And in the meantime, what we actually need is a lot of gadgets during this workshop. So after the participants confirmed the participations, what they actually need is just a laptop, materials, Arduino, HoloLens. And the HoloLens and Oculus headset is actually very optional because the Unity and SDK, they can actually see. I'm sorry. I have a yes. So right now, just to summarize, the requirement skill for this workshop is actually just 3D modeling, and it will be better if you play games because we are trying to design this interaction. So a lot of all this interaction comes from game design. So this is just a part of knowledge you might help, but all in all, you can actually just participate to play around and have fun. So yep, thank you very much.
Thank you, Sky, and also thank you to Nick, Nero, Virginia, Kaiho, and David. So now I'm going to hand it over to my colleague, Ipista, and you can start the next session. Thank you, and thank you, everyone.
Hello. Thank you so much, Chao. Am I audible? Hopefully, yeah. Let me just share my screen.
Yeah, you're audible. Yeah, you can share.
Yeah, just one second. So, good evening, everyone. Sorry, good evening from my end, I think. So, continuing from the workshop that Chao introduced, now we will be introducing workshops that are actually spanned through the 3 different time zones. And before we begin with the presenters who are here, I would like to just cover up the workshop that some of the presenters who couldn't make it. So we have like 4 main themes that are being covered, like AI, structural design, AR, VR games, and robotic fabrication. So under AI, Joy Mandal will be talking about predicting subjective evaluation with neural networks. Shane Bugni will be presenting 3-dimensionalizing GANs. And Emmanuel Ko from Singapore, he will be presenting neural sampling as their workshop. Under structural design, we have Luigi Akunto and his team exploring the structural forms using vector-based graphic statics. And under AR/VR, we have Uttam Salanki from View Reality, and he will check with us about how architecture works in terms of game engines and immersive experience. We do have 2 workshops under robotic fabrication. One is with Sarah Kodarin, and the second is with Hanadi Salim. They are from the American University of Egypt, and they will be checking how we do robotic 3D printing in clay versus VAM. And we also have a speculative future thematic workshop, which will be conducted by Alex Webb, and he will be talking about narratives of the post-Anthropocene. So, not like delaying further, I would request Prashant and your team, like Veena, Ayush, and Pavel, to present their workshop. They are from Saddle Shoe. Prashant, the floor is yours.
Hello, hi, thank you Digital Futures for having us. And Veena is also with us, and she will share the screen. Yeah. So we are architects and artists. We are all from Städelschule architecture class from Frankfurt, and we are all coming from different expertise of backgrounds such as urban design, aesthetic practice, and advanced architecture. But what we have in common is an interest in spatial aesthetics and thinking about form and space through technologies such as augmented reality, virtual reality, and artificial intelligence. So just briefly talking about us is I'm an architect and artist based in Frankfurt. Veena is also an architect working with Klein Architects. Ayush is working at Studio Fuxas in Rome, and he is also running remote collaborative practices. And Pavel works as an architect, and his recent projects were about AR and mixed reality applications. Yeah. And what we're doing is we have the workshop titled as Image, Objects and Fictions. And in this workshop, we aim to operate in a post-orthographic phygital space, which is a combination of physical and digital. The workshop will focus on engaging immediate surroundings environment and activating them with augmented reality. It will examine influence of images in architecture and its effects on reality. In course of the workshop, the participants will produce digital objects through 3D scan and GAN and activate them back in real environments as augmented reality applications. The workshop will also introduce the participants to various texts from Roland Barthes, Italo Calvino, and Georges Perec, and to think of augmented reality as something which can trigger certain aspects of architecture, such as memory, desire, poetry, and science. So briefly, our learning objective consists of building spatial narratives using tools of augmented reality, photogrammetry, and GAN, and blending the physical with the digital. The software prerequisite for our workshop is brief and basic handling of 3D software such as Rhino, 3D scanning, photography, and a brief understanding of Unity interface. The workshop will also share with students Unity and 3D modeling tutorials, which they can go back, listen, and they can make their own augmented reality applications with it. So this is the brief outline of our workshop. It will happen in the course of 6 days, where we will have small sessions of 1 hour each. In the beginning, to introduce them to theory, introducing them to tools, then slowly diving into technical tools of photogrammetry and GAN, and then making tests and sampled results. And then we will eventually introduce them with AR. And in the end, we will also dwell upon the idea of narrative and how the physical interacts with the digital. So there are 2 ways in which we are operating with image. One is with GAN, and the other is through photogrammetry. Through the course of workshop, the participants will not only use these advanced tools, but they will also learn of how important images are in the architectural discourse and how to speculate on the role of image in contemporary architectural design. The participants will then be able to scan their own environments, curate this collection of images based on their own interest, and then they would in turn use these tools to produce architectural objects with certain material effects. We hope to put the objects from participants together and initiate a conversation on their interaction with the reality and inter-object relationships, and to dwell briefly on speculative fiction. We also bring in our workshop the concept of virtual. We will be using augmented reality as an interface to superimpose the virtual space on the physical. And our main intention is to go back to these readings of certain authors and how the students or the participants, they can produce these augmented reality applications in a way to build narratives and storytelling about spaces.
So to begin with the augmented reality part of our workshop, we would like the participants to use AR as an interface to superimpose the virtual onto the physical and to analyze the effects of the intimacy in these 2 mediums. We would like to closely read the relationship produced by these architectural objects within themselves and with their new surroundings, and whether the augmentation and the physical fit or misfit. With this, we aim to produce a variation in architecture by how mediums today might interrelate and coexist in the third space or the phygital space. There's a quick video that I'll share. So that was all from us. Thank you for listening and looking forward to seeing you in the workshop.
Thank you so much.
Next, on from us is Anna and Andrew. Yeah.
Thank you, Psita. I'm gonna share my screen. If I guess you can see my screen. Well, thank you for. Oh, sorry. I'm sorry, I have a small problem here. Sorry, sorry for this delay. We are Anna and Andrew. I want to thank you, Neil and Philippe, again for the ongoing invitation, and Ipsit and Gustavo for the organization and the whole team. This year we are going to be giving this workshop called Conformations with Andrew. Andrew and I have been working together for many years. We were based at DiTela in Buenos Aires for many years, but now I'm sitting in London as I'm doing my PhD at the Architectural Association, and it's from here that the research is taking a certain kind of different stance at this moment. This time we will be proposing a workshop that consists in challenging the idea of simulation in architecture, trying to surpass the notions that are more phenomenological or purely bureaucratic of energy efficiency. And we will be looking at the idea of formation and simulation to kind of approach the idea of trade that is based also on a Deleuzian understanding of attributes and singularities. And so the workshop will be always looking at both sides of the techniques, but also the reasons by which we use these techniques, and what do they mean in terms of being part of a lineage of thinking, of computational thinking. In this case, we have chosen some formations that we can find as open source 3D scans already available on the web, and we will be looking at different formations like parallel ridges, like smooth concentric organizations, concave rocky formations, striated volcanoes, linear and ruggous formations, among others, to actually implement simulations of comfort directly upon these morphologies. We will be simulating sun exposure and wind speed upon these geological formations. This is an image knowledge that overlaps readings of the geometry of the formation plus the readings of the simulation as material, like literally not as a pattern or as a representation of something else, but intrinsically related to the architecture of this artifact. And from these constructions, we will be working in this process. Like the workshop will be structured along these three phases. First, phase of evaluation of the formation via concavity and slope evaluations. Then a set of simulations of comfort upon these formations regarding sun hours with Ladybug and wind speed with a butterfly plugin. And finally, the third stage is the architecturalization of systems, which come from the interaction and the frictions between the previous two conditions. And we will be designing material systems embedded in these organizations, and also designing singular notions of comfort to kind of inhabit these artifacts.
Andrew, yes. So first, as Anna was saying, we will be dealing with formal evaluations. We will be working with meshes that come out of 3D scans of rock formations, and we will use Grasshopper to measure degrees of concavity and convexity, as well as slope measurements. The numeric values contained in each of the mesh vertex will be organized in such a way as to cluster them, and either by creating internally homogeneous regions or extremely heterogeneous ones. Then we will be working with Ladybug tools, specifically Ladybug, the one there in the middle, to simulate the radiation and sun hour exposures onto these formations that are scattered, as Anna was saying, across the globe. And after that, we will be using Butterfly to simulate wind dynamics on those same formations. And finally, after that, we will be working on the relationship of both sets of evaluations and simulations, which Anna will be talking a little bit more.
Right. Yeah, so the structure is pretty straightforward. We are going to be doing this workshop for 5 days, from Monday to Friday, plus final review. We'll be working in 2-hour sessions in these different, we translated to the different hours. So we are trying to reach as many of you guys as possible. We think we can have a lot of fun doing this year. And as you can see, the sessions are always dual. We will be implementing tutorials, so you're going to be learning the tools, first like modeling in terms of extracting these organizations of the concavities and the slopes, and then we will discuss the results that you get. The same with the Ladybug and the Butterfly tutorials, so there will be like this component which is highly learning the skill, and then immediately after we will be discussing the results to build the architectural project step by step as you get the simulations on your table. And the last 2 days we will be implementing a brief that will be kind of negotiated between the participants and ourselves, like, about what are the material systems that are emerging from the previous. So it's not a top-down kind of brief, but more like something that will emerge from the discussions on the 3 previous days. And finally, we will be having some feedback on the architectural proposals to lead to this final review on Saturday, where we will have some invited guests and we'll have a broader conversation. We are on our side. We are 3D printing these samples, and we will aim at having 3D prints of your proposals also as results. So we will speak about that, either each one at their hometowns, but also we can centralize 3D printing here. So we will speak about that. And the results that we expect are like speculative results. Right now, of course, we don't have any project that already does what we are proposing, but we have certain kind of inspirational projects like Parent and of course like architectures that try to articulate these problematics of organization with the formation as not as background and not as naturalistic or vernacular problem, but more as an organizational structural relationship between forms and of an architecture that becomes geological and embedded in the notion of our, let's say, our Earth formations. So yeah, we're very happy to be here, and hopefully this came through clear. If you have any questions, for sure you can approach us on the website. So thank you so much again for having us, and looking forward to this week.
Next is Shashank. Yeah,
thank you, Psita. 1 second. Share my screen. Okay, can you guys see my screen?
Yes.
All right. Hi, thank you, DigitalFUTURES, for inviting us. So we're taking a workshop on digital fabrication techniques, where my partner and I, Sujay and Shashank, we are going to look into all the different aspects of what digital fabrication entails, and the problems, the pros and cons with it, what comes up. So Sujay is an architect, as am I, and Sujay is also a researcher, and right now also heading the design and digital fabrication hub in Sacred Heart School. So we have a 3-day workshop. What we are doing in that 3-day workshop is, in the first day, we will be introducing all the different types of fabrication techniques which are available for architects and designers, which many of us, what I feel, don't know of, and how do we actually exploit those tools to our benefit. And there's not just about how from digital to how we fabricate it. Like, there's a file to factory setup, which will be also introduced and talked about. And also not just that, but also we'll be taking a deep dive into how installations work, and how crazy designs can be simplified and taken ahead into those aspects of it. Next is, this will be the first day introducing into it, taking certain prototypes, making certain prototypes, and also making a small demonstration, which is 1:1, which will happen in the first half of the second day. So the second day, then after doing that demonstration, we will jump into the robotic fabrication, which is a bit more intensive, and where we are looking again into how robots as such can be controlled via softwares and different plugins, and also how end effectors, what are the different types of end effectors, how do we fabricate those end effectors, how do we use those end effectors with path planning and fabrication strategies. So this will also go into the third day aspect of it, where again what we will do is we'll do a small prototype with the students. And one of the things that we thought would be interesting, that we would have our mode to be more hybrid, so people who are staying in Mumbai could come up to the Sacred Heart School of Design Hub, where we have that facility of the robotic arm, the laser cutter, and 3D printers. So what happens is that there's an online session at the same time. There's a physical aspect of it where students could come in, touch the material, and also see how they all work. So in short, the schedule is like this in front of you. So first day, introduction to the strategies, tutorials, workflow, the first day. Second day, going into demonstrations, and then going into the robotics aspect of it. Who can apply is, we are looking at for beginner knowledge, who knows Rhino and Grasshopper, so it's open to all. It's not very advanced. At the same time, if there is somebody who is interested in advanced aspects of it, we will be looking and talking to them more about it. And also we will try to keep it as interactive as possible, so that if there are any questions and answers, so we can always help our students. So that's our workshop.
Thank you, Shashank. Next up is Kedar. Are you here? Yeah.
Yeah. Hi, can you hear me?
Yes.
Share my screen. Okay. So I hope you can see my screen. Okay, I'll leave it here. Yeah, I hope you can see my screen.
Yes, we can see your screen.
Okay, perfect. Thank you. So, hello everyone. I am Kedar. So, thank you for inviting me to propose a workshop for digital futures. So, I am proposing a workshop called Computing Kirigami. Before that, a quick introduction about me. I am an architect, educator, and an artist. In my architecture side, I use parametric design to create spaces that are responsive to climate and context. I like to take classes and educate people about parametric design to make the design principle more accessible. These are few of the posters for Interaxis in Canada and for SJP School of Architecture in Bangalore. I also like to use parametric design to create visual outcomes. So this was in collaboration with a sound artist to see how music can be used to create beautiful forms in parametric design. So just a brief overview about me. Now, like I said, the topic that I want to take workshop this time is called Computing Kirigami. Here is a video which will explain you more of the process of how the workshop will be done. So what we're going to do is that we're going to create folding models that we will then use any plotter or printer to make it into reality. So why this particular topic is that when I was approached to take the workshop, we have been working with a lot of in the digital world from the past 2 years, but we have lost the connection with the physical world, where we kind of touch the materials. Even if we touch the materials, the robotic is doing the job for us. So what I wanted the connection between the digital plus physical, and also to have an accessibility to it. So we know that paper is the most accessible material to all of us. So I wanted to have a workshop which combines all of three. And the first idea was to work with origami. Then for the research, I found there's a technique called kirigami, which is a variation of origami, in which you just play with paper, and when you fold it, it closes the form, and when you open it, the form is revealed. So this is how the outcome will look like of the participants, where everyone will be working with one A4 paper to create their designs. The workshop will be carried for 2 hours each day from 27th of June to the 1st of July. And in terms of the workshop steps, we'll be using Rhino and Grasshopper. We'll be making the base form in Rhino 3D, and then with the help of Grasshopper, we'll create the folded model and also the 2D drawing. In terms of the requirements, we'll be, like I said, working with Rhino and Grasshopper. So anyone with a basic knowledge of any 3D modeling software like SketchUp, AutoCAD would be perfectly suitable for the workshop. And if you have basic knowledge of Grasshopper, that would also be fine. A requirement of A4 printer or plotter, a black and white printer or plotter is also perfectly okay. And physical modeling tools like cutter, rulers, and so on and so forth. So what we'll be doing is that we'll be working in a constant loop, that we will make a base form, use Grasshopper to kind of give us the folded pattern, print it, cut it, and see how many variations we can get. So it's a short exercise of 2-3 hours, and then until we reach a final outcome. So at the end of the workshop, each student will have different options of the models and also different sheets to explain their design. Yeah, so that's the short introduction about my workshop. Thank you.
Thank you so much, Kedar. Next is Carlos and Harry. Hi. You can start presenting.
Hi, everyone. Let me share my screen right now. Hi, DigitalFUTURES. Thank you for the invitation. We're very glad to be here this morning. So the title of our workshop is Performative AI, Neural Models plus Agents. And our team is conformed by myself, Carlos Navarro. I am a master in design research from SciArc, and also Harry Moller, who is a master in architecture and digital fabrication. Just to give an overview, this workshop grounds itself on a common interest of the team regarding materialization of AI models using GANs and the use of the Unity game engine for ML agents behaviors. These are past explorations from 2021 that carried us to propose this new workshop. So the workshop, again, grounds itself on current widespread research on neural network-based image generation models and explores their potential agency for 3D reconstruction of performative environments for machine learning agents. A range of AI models is to be studied in the hope of superseding manual 3D modeling of the architectural form-finding process. The workshop objectives are learning about state-of-the-art image synthesis and text-guided AI models, understanding of datasets design for GANs and text prompt designs for diffusion models outputs. So these outputted latent space images will be 3D augmented based on molecular depth estimation AI models. And then the performative analysis of image-based morph topologies, interaction with ML agents using the Unity game engine. The required skills for this workshop are just basic modeling skills, and understanding of texture and displacement shaders, basic notions of the AI models with Google Colab, basic experience in Unity game development and/or work with agents. Experience in procedural design and visualization is advisable. Again, this workshop will provide an overview of image synthesis AI models such as StyleGAN and SceneGAN, and also text-guided AI models such as DALI, Disco Diffusion, and Clip, to eventually identify and compare the agency of these data sets and text prompts as avenues for image generation. The usability of the text prompts will be leveraged in this workshop to produce latent space, as we can see in this image. And then curated checkpoints will be identified and 3D augmented using this molecular depth estimation model called MIDAS, that is nowadays used for AR devices, in order to compose or generate actual 3D geometry that can be analyzed, that can be further analyzed. And then the latent space material condition will be also studied in exercise of morphing topologies. Yeah, Harry, you want to continue?
Yeah, I think ultimately the performative agency of the latent space will also be studied in the search of morphing topologies that machine learning agents can learn from to optimize math navigation performance and program view simulation. In the end, the workshop's goal to generate an autonomous architectural form-finding entity with controlled levels of supervision within a collaborative environment that lies within an AI interdependency and human control while challenging and augmenting the designer's role, trying to, on this interpolated workflow, we did the SceneGANs and the Unity that can explore and the form finding and the behavior by putting agents itself. And this is a couple of examples we'll be doing. Carlos and I were using point cloud models or surface models, and by inserting agents, ML agents that can work around it by certain conditions and rules. And this is the intention of performative analysis, performative design, to have a better automated workflow of form finding by using Stalagans and machine learning agents. I don't know if you wanted to.
Yeah, we are ultimately trying to leverage the power of the Unity game engine and its BFX tools to not only reconstruct the inputs that we get from the AI models, but to construct new architectural entities in a collaborative environment between the AI and the user. Yeah, so thank you. This is the brief overview of our workshop.
Thank you so much, Carlos and Harry. Up next is Patrish.
Yeah, hi.
Hi.
So I'll just share my screen. Just a second. Yeah. So can you see my screen?
Yes.
Okay. Hi, everyone. This is Patrish, and I'm quite glad to be here and very excited to present our workshop today, Biodata Flows on Mathematical Structural Forms. First of all, I'm quite grateful to the amazing opportunity that the Digital Futures team has provided us today. And a big cheers to our coordinators who have been very patient with us in the entire process. And thanks a lot, guys, Ipsita, Bhavleen, and everyone else. So beginning with a bit of an intro, I'm Patrish Kumar, and I'm a computational designer based in India. And I'm currently a research associate at Ardena and educator at RATLab Education. My research interest lies in the paradigm of generative design, focused primarily on discrete design methodologies and optimization workflows. And along with me, there will be 3 more co-instructors in this workshop and who also happen to be my colleagues at Ardena. Firstly, Crispina. She's an architecture student pursuing her final year at Chennai, Anna University. She's also a computational designer and an architectural journalist. And then we have Mohammad Sakleen Khan, who is an architectural student and an aspiring data scientist from NIT Patna. And finally, our final instructor is Mahdi Fard, who is also kind of a mentor to us in this workshop. He is the founder of Ardena and experienced professional for past 6-8 years in AEC industry. He's an architect, programmer, and much, much more. So coming back to our workshop, as titled Biodata Flows on Mathematical Structural Forms, in this workshop, what we'll do is we'll try to integrate natural patterns and growth algorithms onto mathematical forms. And then we'll try to optimize these structures that will generate with the combination of the patterns and the surfaces to using an evolutionary solver and using machine learning algorithm. So our workshop is structured into 4 days from 27 June to 38th June for a period of 3 hours from 9 p.m. to 12 a.m. on Indian Standard Time. And on each day, we are targeting a particular learning objective, and that's how we're going to approach this workshop. So the first day, what we're going to do is Madhi would take a basic introductory lecture, sort of providing a bit of literature to us and setting up the premise of the workshop, followed by the first session, which would be taken by me on mathematical surfaces. Especially, we would be working with minimal surfaces. So we'd understand what are they and how we can create them in Rhino Grasshopper using the plugins of Kangaroo, Millipede, and Chromodoris, using mathematical equations and form finding techniques. So once we have our structure ready, so then on day 2 with Crispina, we would first understand the natural pattern that we're going to use in this workshop and sort of how we can integrate that the natural pattern onto our minimal surface using the Parakeet plugin. And on the 3rd day, we will bring in Karamba to sort of determine the relevant parameters in our design and the fitness criteria in our design. I would like to note here that Karamba, we won't be diving deep into Karamba. This will be just primarily to establish the main parameters of our design, so that it would aid in our optimization workflow, which will be the theme of day 3. We would be learning about the evolutionary solver Wallacey, and we'll learn how to do an optimization, what is an optimization workflow, how we can sort of use the design parameters and fitness criteria to arrive at an optimal solution from a series of design iterations. And once we have this entire workflow ready, on day 4, we'll move out of the Rhino or Grasshopper workflow into a Python-based ML workflow. And sort of to familiarize the participants with the code and with ML, we'll take a short introductory session on Python, which would be covered by Saklain. And he would be walking us through with the basics of Python and sort of sharing us a couple of projects so that in the final session, the students would have, will be easy for them to grasp and sort of understand what they're going to do, which would be taken by Mahdi. And in the final session, we would be implementing the machine learning algorithm k-means clustering to kind of arrive or converge at the recorded data from our design iterations onto the features that we want. And we can sort of use so that once we can determine our features, we can the participants would be able to use the design parameters in a recursive manner to make their design more intelligent, sort of having been correlated with the biodata flows and post flows. So all in all, in this 4 days, we would be learning a quite rich and comprehensive workflow containing segments from different domains brought into a single particular workflow. And in fact, each of these parts the students can use even independently for their own research and design workflows. But yeah, they would be learning a quite comprehensive workflow. So, and the expected result would be that the students would be making their own structures, developing their, applying the pattern and running the algorithm to arrive at their own outputs. And we would be having a final presentation on the works done by the students. So coming to the softwares that is necessary for this workshop, we would be requiring primarily Rhino Grasshopper, and you will be using Python 2.7 and Python 3. And the number of plugins that has been mentioned currently, we would be actually providing the entire workshop package to help you set up before even the workshop commences. So don't worry about that. And regarding who can apply this workshop, in fact, anyone with a basic knowledge of Grasshopper and Rhino can come into this workshop. Do not worry about if you don't know about Python. That's something we will brush over, and that part actually would just relax and watch us how we're going to do it and just follow us through. So yeah, so this quite excited and hope you guys are excited as us and looking forward to the workshop. Thank you very much for having us. Yeah.
Thank you so much, Patrish. Tagbir, are you around? Okay. Nihar, are you ready? You can go now. Yeah, thank you.
Hello. Thanks, Apsita. For the past year, we at YemiTech have been combining data technology, geospatial awareness, and placemaking expertise to ensure the community needs stay at the forefront of new urban development. Together with DigitalFUTURES, we are bringing some of these ideas and processes into a workshop titled Rebuilding Communities Through Data Insights. Our design practice, Yemi Architects, has been responding to these increasingly prevalent trends through spatial design approaches that integrate socially beneficial intervention. We started YemiTech to augment these ideas further through our community data platform and broaden our reach. The objective of this workshop is to understand the intrinsic, as well as extrinsic forces that minimize community cohesion. Building on these understandings, we aim to propose interventions that are human-centered, appropriate, impactful, and sustainable for the future. We will be using the processes of data gathering, data categorization, and data enrichment to digitally map various characteristics of an area and its communities. To use mapping as a tool to investigate urban areas, we expect the candidates to simply have some primary understanding of urban cartography. The aim of this workshop is to create visual arguments that can support planning of interventions and protocols. Our key tools will be charts and maps to convey the findings. These will help to highlight key shortcomings and challenges that can be addressed through informed strategy development and planning proposals that empower and uplift communities. We look forward to sharing and discussing with you different ideas through this workshop. See you there on 27th June. Thank you.
Wow, thank you so much, Kushal. Next, Tagbi, are you here? Yeah.
Yeah.
You can present.
Thank you, Ipsita, and thank you to Digital Futures for including me this year as well. I'm Tagbir Fatima. I'm an architect, educator, and I'm the director of Design Aware, which is an interdisciplinary experimental architecture and design studio, which is based in Hyderabad, Dubai, and many other places virtually. And also I started this workshop called the Fractals Workshop. It's been 10 years now, and this is going to be our second iteration of analog algorithms for digital futures. And last year was the first time. What really appeals to me about Digital Futures is the idea that design education should be accessible to all, and it should be inclusive. And this is something that it's a cause that we've been championing at Design Aware as well for quite a few years. And so we're happy to participate and to be a part of this cause. The Fractals Workshop has been around for 10 years this year. It's been to many different cities, and we've used many different materials and conducted 32 workshops, and this is going to be our 33rd iteration. It's also been featured in quite a few different publications over the years. And as the name suggests, the Fractals Workshop is really inspired by the growth of natural systems, particularly fractals. So we'll be learning a little bit about that, and also learning about how these, how the growth patterns occur in nature, and how we can adapt those, and we can learn. Workshop not only aims at studying fractals, but also kind of looking at the very basic building blocks of parametric design and of algorithm-based design. So this is, I would say, it's really aimed at people who are really interested in computation, in mathematics, geometry, form finding, but also are finding it really intimidating to get into computational design. And so this workshop aims to kind of bring everything down to its very basic building blocks to learn about how algorithms are made by first using your hands and using materials. So that's why we call it analog algorithms. So we have an analog understanding of algorithms to begin with, and then we get into computation. So the premise of the workshop is that many minds and many hands can come together to create something that is much greater than the sum of its individual parts. So these are some of the, this one's not playing, but these are some of the examples of the way the workshop is structured. There's a wide range of approaches that we take, from purely analog to design and build. These are some of the design and build exercises that have been done in the past. This is in the city of Hyderabad. These are permanent installations. This is in Vellore in Tamil Nadu in the south of India, and in Dubai as well. And these are permanent installations which are located there, which have been a result of the Fractals workshop form finding explorations. What I really love about this workshop is that you can start from scratch. You can start from not knowing anything to taking it to whatever level you are comfortable with. So, and the other aspect of this workshop is collaboration and a kind of collective intelligence. So these are some of the workshops where you can see that it's really derived from analog exploration, and then it gets into computational design as well. So these are some assembly systems which were created collaboratively by different students of design. And then we will be, for this particular workshop, which is going to be held online, we will be getting into virtual reality and exhibiting the outcomes of the workshop in Mozilla Hubs as a virtual exhibition, which is a perpetual exhibition, which we intend to continue to create together and also to continue growing together. And it's perpetually open. These are some of the previous explorations. And so, as I said, you can take it to whatever level you want to. You can kind of translate that into something that is analog and a large-scale real-world sculpture, or you can get into speculative virtual worlds as well. And we've been having a great time the last couple of years where so many different people from different places all over the world were able to connect. Even though it was there was a lot of analog work involved, we were still able to collaborate, and we were able to create something together virtually. And we also did a few hybrid sort of crits and juries, which were really interesting because we were able to get people from different parts of the world to give inputs to the students and the participants of the workshop. I'm just going to play a little video from the middle of it from last year. So this is us, the way we were working last year during the during Digital Futures. And you can find this video on YouTube as well, on Design Aware. And I think these are some of the outcomes, and you can see the evolution of the explorations. So they go from analog and paper models to something digital, digital explorations, and then into virtual reality as well. And this video, I think I'm not going to go on for the sake of time, but this is available on YouTube, which you can check out. And of course, to give you an introduction, a little bit about myself further, I've been teaching this workshop. I created this workshop about 10 years ago. I've taken it to many different schools of architecture and design all over the world, as well as Dubai Design Week, Hyderabad Design Week. And I'm a graduate of the MArch program at the Architectural Association Design Research Lab, and after which I started Design Aware and the Fractals workshop. And the prerequisites for this workshop are, I would say, just basic design, basic 3D modeling. Even if you don't know Rhino at all, that's completely all right. You can start from anywhere. And this is ongoing, open-ended design research. So it does not really have a kind of starting point and an ending point, and there is no specific kind of outcome that we're looking for. So anything you want to do, you will be learning the skills or learning the way parametric design or parameters of generative design are developed using these analog algorithms. So basic 3D modeling is fine. Craft and physical modeling and kind of a propensity towards geometry. This is something that I would say really would help you. So we'll be using Rhinoceros 6 or above. We won't be using Grasshopper. It'll be a very, very basic building blocks kind of workshop, which is open to anyone from any skill set. And we'll also be learning about Mozilla Hubs. this is the agenda for the workshop. We begin with the analog exploration, and then we talk about the design process, and there is a lot of self-evaluation involved, and of course, group work and peer-to-peer learning. And then we get into generation of larger scale aggregations, and then documentation and exhibition. And by exhibition, of course, I mean virtual reality exhibition that we will be building together, which will be a continuation of the exhibition from last year, which we'll be building upon and adding to. And yeah, for more information, you can go to fractalsworkshop.com, as well as DesignAware, Fractals Workshop on Instagram. And these are our hashtags. Fractals are everywhere. Thank you.
Thank you, Takbir. Lungia, George, and Don.
Hello there. Thank you.
Hey, hello, we are the team GSD. So the name of the workshop is the Generative Metaverse, the machine learning application in design. So this is the development from the last year workshop at the DigitalFUTURES named the Machine Intelligence. So yeah, we are three here, or the GSD alumni, and we also have some different background, like technology and the MR degree as well. So let me introduce myself first. So hi again, I'm Donghyun. Actually, I was the architecture student as well, and I'm also pretty serious student. So, and then I'm just a little bit changed my career path. So I will be working as the creative lead and the machine learning engineer in the Silicon Valley. And so I know what you will be struggling with. So I will help you develop the project and make some of the progress from the early design stage to the final. So don't be daunted.
Hi everyone, I'm George, and I've currently graduated from the Graduate School of Design, and I've been doing research for the past few years, machine learning applications in architecture, and I look forward to bringing forward new design applications within this space.
Hello, everyone. This is Chen, and I also have a background in architecture and deep learning. And this is a great development from last year's previous workshop, and we're gonna add in some new contents regarding generative metaverse. Next one.
Okay, so with this workshop, we'd really like to bring students on a journey to revisit the relationship between spoken and written language and architecture, as well as the current notions of what we're describing now as the metaverse. So generated through a combination of the latest machine learning models, these generated images emerge from text inputs, where semantic specificity is critical in defining output images. So its applications in architectural design really bring forward new opportunities and forms of collaborative design. Can you still see my screen?
Yeah, we can see the screen.
Okay, sorry, my screen is black, but I'm gonna try to keep going.
But we see the presentation. We don't see the slide show or the preview. Maybe you would want to share again.
Sorry, I'm gonna have to rejoin. 1 second. Do you see PowerPoint now?
No, we see the WhatsApp chat. So maybe I can stop the screen share for you, and you can share again.
If you could, thank you.
Yeah, please try, George. If you did, yeah, you can try again now. Kim, I think George frozen. Do you have the slides? Do you want to share? Or Runjia, do you want to do that?
Actually, just Georgie only have the slides, so I think he needs some the reboot the computer. So I will
Okay,
just
so let's do one thing. We can move to the next one and come back to you guys.
Yeah.
After he joins. Okay, great. So Ipsita, we can't hear you.
So Anokhi has sent us workshop preview. So I'll just share the video till then. Yeah.
Perfect. Let's do that.
Hi, I'm Anokhi Shah, the founder and creative director at IOVR Space, also the curator of the New Media Festival at TIFA Working Studios. Into the Metaverse will be a 10 to 12 hour long workshop series spread over the span of 3 days. So what is the Metaverse? The Metaverse in a nutshell is a digital world where anything we can imagine exists. Eventually, we'll be connected to the Metaverse all the time, extending our senses of sight, sound, touch, blending digital items into the physical world, or popping into fully immersive 3D environments whenever we want. That family of technologies is also known as extended reality or XR. This also includes virtual reality, VR, and augmented reality, AR. Today, we are already seeing shadowy glimpses of what the metaverse may soon become. It's not going to be a totally new thing. We are already used to avatars and exploring virtual worlds through different platforms on the web, through games, through our phones, etc. Stemming from principles of video game design, we look at storytelling, characters, style, interaction, and more. This workshop will lay a primary foundation for the creation of virtual worlds. We will mainly be using Unity 3D to create these worlds. All students are expected to have basic 3D modeling skills so we can create assets and bring them into this virtual world. The workshop also encourages participants to take conceptual risks and develop their own new modes of representations using Unity as the main game engine. Students will put their creative skills to work by generating and engaging with world design as a personal project. They will also outline their project's conceptual, narrative, and aesthetic elements. We will also discuss what the metaverse is, why it's so important, what are some of the current trends, and what we might expect for the metaverse going forward. As the final expected outcome, each student will have his or her own individual project of a mini metaverse or a digital world created in Unity 3D, relevant documentation such as presentation slides and videos explaining the development process and the final world. If you have any further questions, please feel free to reach out. Thank you.
So yeah, that was Anoki. George, are you ready to go now?
Yeah, apologies for this. Okay, so thanks again. So with the workshop, as I was mentioning earlier, we'd really like to bring students on this journey to revisit this relationship between spoken and written language, as well as architecture and current notions of the metaverse. So generated through a combination of the latest machine learning models, these generated images emerge from text inputs, where semantic specificity is really critical in defining these output images. Its applications in architectural design really bring forward new opportunities and forms of collaborative design, which is described by Professor Sturla in this case, where new synergies really can emerge between us as designers and AI, where these feedback loops, this idea of human agency and this process of curation and selection and generation of these images really become fundamental in this design process. So we'd really like to extend last year's questions on whether the design outputs would pass this architectural Turing test. So these are some this is an overview of the workflow we'd like to cover within the workshop. And as we've really reached this moment of convergence between text and image processing, we'd like to start with this idea of text to text or text to image generation through CLIP or DALL-E models using Colab notebooks. This idea will then extend to 2.5D grasshopper generations, where we'll use Midas and several other machine learning models to generate urban or architectural forms. And that will extend to 3D generations. These are some processes looking, for example, on an architectural scale of plans or facades, on what forms could be generated and what types of metaverses we can collectively create. So generally, the basic knowledge of Rhino and Grasshopper is suggested, but it's not required. It's also beneficial to have some basic machine learning or Python knowledge. But the workshop will generally cover the foundational concepts behind these models. We'll go specifically slightly deeper into models such as StyleGAN, CLIP, or DALL-E, as well as Midas and 3D GAN through this hands-on approach using Colab and Grasshopper.
So each student will generate their own proto architecture. Specifically, these will be one or the many urban fragments that we will merge together as our own city, like the captive look. However, now fully the digital and generated by the AI. And also this will be minted, and participants will each produce final animation describing this process. So thank you for watching, and we very much look forward to this workshop again. Thank you.
Thank you so much, George and Donald. So from my end, there's one last workshop recording I'll share. It's from Joy Mandal. He couldn't make it. Let me just share this.
Make myself be present with you guys. So I'm sending in this recording. Let me share my screen while I briefly discuss the content of the workshop. The name of the workshop is Neural Networks for Predicting Subjective Design Evaluation. And before I get into the details, let me briefly introduce myself. I run a design computation consultancy, which is named vSearch Lab. And of course, we offer design computation consultancy to architectural practices across Southeast Asia. And along with that, we also release certain software solutions. We've released a couple of Grasshopper plugins, which you can access from the Food for Rhino website. One generates Mondrian-inspired 3D forms. The other automates column beam placement on orthogonal floor plans. I have been tutoring workshops related to computation and specifically to the application of AI in architecture over the last 3 or 4 years. This will be the third year running that I will be tutoring a workshop at DigitalFUTURES. Along with this, I've also tutored workshops at other formal design computation conferences such as CAD Futures, ECADI, SIGRADI, CADRIA, and SimAUD. Now, getting back to the topic of use of neural networks for predicting subjective design evaluation, we'll address 3 predominant questions. And this is designed as an introductory course for students or professionals who want to use AI, who want to use neural networks, who want to train neural networks, but haven't gotten their hands dirty with the process. And 3 questions we'll try and address through this workshop would be, how do neural networks work? What is the concept behind them? How can subjective evaluation of design be predicted with the use of neural networks? And all of this will be executed through the use of Google Colab and Grasshopper. The particular exercise that we will concentrate on is we are going to predict the originality of tower designs with respect to the absolute tower D designed by mad architects as the reference design. Of course, that would mean that a whole bunch of example variants of designs will need to be rated by a crowd. The crowd would be me as well as the participants of the workshop. And with the rating of plagiarism versus originality, we are going to train the neural network, which will be able to predict the design originality of all possible design cases. Of course, in order to not only generate the design variants, but also to take the trained neural network and use it for prediction, we will need to use a parametric script. This is an example of a parametric script which has already been used. We're going to use a whole bunch of parameters to change the shape, not only in terms of rotation, but also the shape of the plan from an ellipse to a square to a star-shaped plan. And at the end, one of the crucial things that often gets left out is that we will also address how can the trained neural network be run offline in Grasshopper. So we're going to extract the weights and the biases from the trained neural network, copy those into Grasshopper and use it with a custom component that we have developed at Research Lab, which will help us use the trained neural network within the ecosphere of Grasshopper. In other words, we will learn at the end how to convert the Google Colab trained neural network to a Grasshopper component. And to end, some technical information. The participants would need to have beginner level knowledge of Grasshopper, and the workshop will go from 27th June to 1st of July, and it will be 2 hours per day. I believe the information for the workshops will be uploaded soon, and I will see you live at the workshop. Bye-bye.
Thank you from my end, and thank you for all the instructors with whom I have been associated right now in managing their workshops. And Lamila, let's begin with your sessions now. Thank you for your patience, all of you who are still here.
Thank you, Ipsita. My name is Lamila, and I will take you through the presentation of the next 5 workshops we have. I will share my screen just to show you. I have some problem with the sharing the screen. Moment.
do you want me to share your presentation?
If it's possible, thank you.
Yes,
Lovely.
yes, I'll share. Yeah,
Thank you.
okay.
Sorry. Okay, thank you, Pauline. So as you can see here on this slide, we have 5 more workshops. And out of these 5, 2 presenters or 2, actually 3 instructors from 2 workshops are today with us. So I would like first to call Dr. Alberto Esteves and Dr. Yomna Abdallah from Universitat Internacional de Catalunya to give us information, brief information about what we can expect in the workshop named Biolearning and Behavioral Algorithms for Biodigital Architecture and Design. So Professor Esteves and Yomna, can you share maybe your screen? Hi.
Hi, hello.
Hi, how?
Thank you for the brief introduction and thank you for inviting us, dear Lamila. Now I will share my screen.
Welcome.
And yes, so first of all, good day, everyone, and thank you for having us in Digital Futures. And I would like to give a very special thanks to Professor Alberto Esteves for accepting for the first time to share with us his precious lecture about biolearning in the workshop, in this workshop, despite of his full schedule. So the workshop consists of Professor Esteves and me, as Professor Esteves as invited instructor. He is currently the director of the Institute of Biodigital Architecture and Genetics at the International University of Catalonia in Spain. And he is also the director of the Master Program of Biodigital Architecture, and is the founder of the School of Architecture at the same university. And I myself, I am, I hope you are seeing my presentation. So I myself, I am the Deputy Director of the Institute of Biodigital Architecture and the Master Program. And I am leading the research line of bio-based design, biosystems and biomaterials and their integration in the built environment. And only to go briefly through what we are doing in the Institute, these are from the Genetic Architectures Office, which is also part of the Institute. And here you can see some of our of the projects that Professor Esteves was directing throughout 25 years. So you can, of course, you are welcome to dig more deeper inside. And of course, the famous slogan from DNA to the planet, which is the real integration of biology in the built environment, not just through the form, the design form, but also through the real integration of cells and organisms in the built environment for various functions. And this is what we will speak in, will speak about in the workshop. Also, you are welcome to check the Biodigital Master Program, the master program that was also running from 20 years until now and have a lot of graduates, famous graduates all over the world. You can also check on the website the kind of workshops that we have. And here are some also books of Professor Esteves that can inform you more about the biodigital architecture approach and the correct biolearning approach by its founder, as the term itself was pointed out by Professor Esteves. So going directly to the workshop, what will be presented? Well, actually, we thought to present a smaller or like a kind of a prototype workshop of what we are doing in the masters, in the biolab that I direct in the Biodigital Masters. And in this sense, of course, we cannot abstract the full biolab that is taught during 3 weeks to just 4 days. So of course, we will just present the main concepts of the biolearning and biobehavioral algorithms for biodigital architecture and design. In this sense, we have 2 main pivots of this workshop: the biolearning methodology that will introduce the students to how to look to the bio-inspiration in terms of behavior. And how to extract through different mathematics and mathematical biology, how to extract their logics through algorithms, and how to translate these into formal complexity of these designs. When we speak about a bioactive agent, it means that is a live agent like microbes on the level of molecular biology or microbiology, which can be bacteria, fungi, algae, and this is what we are doing, of course, under microscope. And we will, through this also, will analyze their biobehaviors, not just for growth, their patterns of growth, but also their physiological patterns of, for example, some behaviors that are called chemotaxis or branching or bioluminescence, other activity that they do in nature for survival. And these can be, of course, of a special value and interest for us in biotechnology and architecture as well. And the second part is the biobehavioral generative algorithms, how to generate them through using digital design tools, basically Rhinoceros and Grasshopper. And in this terms, we will use mainly key algorithms as cellular automata, for example, different categories of cellular automata as deterministic or stochastic cellular automata. We will also use differential growth algorithms, and we will see how each algorithm resembles one behavior or more that can be used. And here is one example of one biolab result from the previous years. Of course, as you can see, here is under 3D printing, and here I hope you can see is the branching logic. The simulation of the branching logic of this type was an algae. The bioactive agent in this case was an algae. So the learning objective, each participant will be able to identify the bioactive agent that he is searching for, either fungi, bacteria, algae, and why he identified, what is the function that he is willing to use it for in architecture, for example, to generate bioelectricity, or to perform bioluminescence, or to perform bioremediation role, like to consume carbon dioxide, or to generate oxygen, or to generate food. And from this, he will be able to design something that is called a bioreactor or a biosystem, which is the design of the process or of the performance of this bioactive agent, how to act in architecture. And the second part is each participant will be able to couple the function with the form. From the studied bioactive agent, you will be able, through microscopic images, to extract the logic of this specific function. Like if bioluminescence, extract the specific function and specific behavioral algorithm that is responsible for this one. Of course, in terms of outcomes, first of all, it will be the biolearning methodology and the bioreactor or biosystem or biomaterial or a hybrid system that is generated, and the formal design, and of course a 3D print or a prototype of this design, and the operation in terms of a simulation of the system as you have seen in the video. Also, in the workshop schedule, we will start from 27th of June until the 13th of June. I hope that these are within the margins. And it's for 4 days, and each day is 3 hours, because we suspect that too much biological data that is also mathematical biology data is so heavy to manage in more than 3 hours. So 3 hours is the maximum precision. And in the first day, we will do the introduction of biolearning by Professor Esteves, and the biological processes in design, which is a biotechnology introduction. And in the second day, we will look deeper into the functionalism of the bioactive agent that is chosen and how to choose it. And we will look also into the biological imaging and mathematical modeling, which is the microscopy study of the bioagent. And in the third day, we will start to apply the algorithmic design through these types of algorithms that I have specified before, and through also a number of plugins that can vary from variant by behavioral plugins like Colibra and Rabbit. And in the final day, we will exhibit the final results, of course, from the participants, and also the 3D printed models that we will print in our institute here in Spain. And we will share, of course, online with our students and with DigitalFUTURES. And actually, this kind of biolab workshop that we have been doing also in the masters emerges from our research interest in the institute. And because, as you can see here also, we have to the left hand one result from a previous biolab that it was published in a paper, and you are welcome, of course, to check this paper and to look into the full process of generating bioelectricity through generating a microbial fuel cell that is informed by the bioactive agent, which was algae, the branching logic of it, and also another which was informed by fungi. And with a very simple comparison, you can see that changing only the agent can change the logic, despite that they both are doing the same function. And also, going more deeper, this was inspired by the work of Professor Estevez that was integrating bioluminescence gene in the trees of Barcelona street as an urban lights, sustainable urban lights. And also his project of biodigital bricks that were generated using logic that is extracted from the material capacity of absorbing water, and for being flexible and sustainable, minimum material and maximum structural efficiency. You are also welcome to check this as a published paper, and how to use various materials into this process, which is the other side of this research line, which is the bio-based material. And as you can see here, once it was the same biodigital bricks, once was printed with clay, and here is printed with edible material as a further aspect that we also was proposing. And last but not least is how to integrate both the material and the bioactive agent together in a bioreceptive system to study their interaction together. And here you can see various types of algal strains that were integrated in a bio or hosted by a biomaterial that is also an ongoing research. And these are some results from the biolab that we are proud to share with you from the masters, which was winning the Swarovski Young Generative Competition in 2021. And also this publication that you are welcome to check. And this is from this year, 2022, which was the task was also to create a bioreceptive system for bioluminescence and for the various algal strains. And here you can see that it was generated a tile from biomaterial, and the process of the generation and the recipe of the biomaterial, the formal logic that is generated from the studied algae. And here is also a brick that is generated from the same logic and the printing process of it. And here also we show a simulation of the growth of the algae based on the logic, and some printed other tiles, other examples from biomaterial. So for the printing process of the student results from this workshop, for example, here we are showing the printers that we have in IBAG, in the Institute of Biodigital Architecture and Genetics, and that we can use for printing the results that the students will reach throughout the workshop. Thank you.
Thank you, Amna, for detailed information. Professor Estevez, would you like to share with us a few words, or?
No, it's okay. It's okay. It was all very good display.
Okay.
Thank you.
Okay.
Thank you.
So thank you, team, Professor Esteves and Yomna, for giving us the information about the coming workshop. So now I would like to call Dragos Breskan to give us more
Hello.
information. Hi. About the workshop and about the research interest of you maybe, and of course you, and maybe Angar. Angar is not here, but you will present in his name.
I will present in
Thank
his
you
name.
very much.
I will try to share my screen first of all.
Yes, screen is
Let's
yours.
see.
You can.
Yeah, party. All right, I think you can see almost everything.
We can.
All right. Okay, so hello everyone. My name is Dragos Breskan, and I will be doing this workshop with Angad Warang. We are both architects by nature and computational designers, and we work as teachers as well within WIC, Universitatea Internațională de Catalunya, within the Dubai Digital Masters. And the workshop that we'll be tackling will be generative environmental optimization while using Ladybug and Octopus. Just a little background regarding what we're going to do. We're going to try to create architecture based on information. And most of this information is going to be something that we're going to take from analysis, environmental analysis in general, as well as different aspects of the building that we're trying to make. Just a little bit of ideas of what we're trying to achieve through the workshop would be to understand the site's constraints and the interaction with the development. We'll have to derive some sort of a climate responsive design that will lesser the energy and natural resources. So we're going to talk a little bit about energy efficiency. We're going to talk a little bit about the environment and how we can take advantage of it without damaging. We'll talk a little bit about integrating high performance technologies in order to diminish the critical resource consumption. In this sense is to optimize different places or aspects of the building where we can actually place certain systems or technologies that would benefit from the environment. And last but not least, we're trying to approach an effective sustainability. Now, the idea is to create some sort of a relationship between architecture and the environment in which both of them interact in a very, undestructive way, because usually the environment acts upon architecture and architecture or buildings in general act upon the environment. And the idea is to create a system that has a tendency to kind of learn from the environment and give back. So the tools that we're going to be using are going to be Ladybug and Octopus in this case, of course, within the Grasshopper medium. We're going to talk a little bit about Ladybug and what we're going to tackle. First of all, we're going to do a small studio through which we're going to teach the students or the participants to the workshop how to use the Ladybug tools, especially just the Ladybug part. We're going to have different approaches regarding climate data plots, sun path graphics, shadow studies, and radiation studies. These are the main 4 tools that are being generally used within Ladybug, but we'll go a little more with it depending on how much time we're going to have. Just a little demonstration, the climate plots is just showing a yearly plot based on different weather analysis data, such as temperature, humidity, wind speed, and so on. Regarding wind, we have some wind roses that we can analyze to see from the direction from which the wind is blowing. Of course, there are different tools that help us make a more thorough analysis, such as butterfly that was presented in previous workshops. The workshop being so extensive, we're not going to tackle butterfly, but we are going to visualize the wind data. We're going to talk about sun path graphics to see the sun position in different moments of the year, or maybe take them as reference in order to generate geometry, and as well as learning how to map certain information on the position of the sun. And we'll have shadow studies based on direct sunlight hours, as well as radiation studies, which are the cream of the crop regarding Ladybug in itself. So apart from that, we're going to look a little bit towards multi-object optimization. This is something that Angad will help us tackle, which is in general multi-objective evolutionary optimization. Is kind of similar to Galapagos, which was made by David Groton within Grasshopper. The difference is that it allows us to get multiple results at the same time, or multiple inputs at the same time. And it introduces this Pareto curve, which basically means that you would get a better result at the expense of the other one. And a small demonstration of what we're going to be trying to achieve. Let me try to play this. Let's see if I can. Okay, so the graphics are a bit weird. In this case, I can see it in black. I don't know if you guys see it correctly or not. Okay, now kind of looks all right. Is the idea of developing a certain morphology based on direct sun hours, following the landscape itself, following the context, and ensuring that you get the most sunlight in the areas that you would want. This would be pretty helpful to create some sort of a voxelization of geometry that would take into consideration almost everything around within the environment. And apart from that, it could be taken either in sun hours or in direct sun, in radiation, or in different aspects. Moving forward, let's see if I can just click next. All right. Yeah, some of the other plans that we're going to have for the workshop would be different morphologies that will generate through the building skin, which would be having a certain surface, which is parameterized and then optimized to have a certain performance. We would look at different morphologies based on the cardinal systems and how to basically create a building regarding the sunrise, sunset, and so on, and different building parts and how they would interact with each other. One of the final steps of the workshop would be to focus on the skin itself in terms of different types of facades, may them be static or kinetic, and see their influence upon the building itself. And even more than that, to have them perform at an optimum status. So basically what you see here are different results that we've done with the students in previous years within the Biodigital Masters, and as well as within Digital Futures last year. And the basic requirements are, beginner knowledge within Grasshopper, preferably a Windows PC, because usually there's certain aspects on Macs that do not go very well with Ladybug or Grasshopper, but they can be managed. So it's just preferably, and of course Rhino 6 or 7. And as a time frame, we'll have around 2 to 3 hours per day. We're going to span this over 6 days, starting with an introduction on the 27th of June, where we're going to talk a little bit about energy efficiency and computation evaluation, and how these two themes react or go together or not go together in certain cases. We're going to have a dedicated Ladybug studio for one of the days. We're going to have another dedicated studio for Octopus in another one, after which we're going to start combining them and having some generative applications for general morphology. So we'll try to grow something. Then we'll start looking towards facade behaviors. And then within the 2nd of July, we'll try to wrap up everything and get some results with the students. This was basically it. Thank you. Thank you very much, Lamina, for the invitation. Thank you, everyone from the Digital Futures, for being here. And I hope that you guys will join.
Thank you, Dragos. I'm quite sure that we will. So if I just may ask above me to share in my name, to just announce 3 additional workshops in the name of the instructors, because unfortunately they are not present here today.
Yeah, just give me a second. Yeah.
Okay, super. Thank you. So maybe I can start while we are waiting. So title of the workshop, Distributed Cognition, Artificial Intelligence and the Complex Adaptive Hybrid Processes, will be run by Dr. Anna Cocho Bermejo. I apologize if I'm not pronouncing the name well. So Dr. Anna is the co-director of the Master in Artificial Intelligence for Architectural Design at the Universitat Politécnica de Catalunya, Barcelona, Spain, together with the Professor Josep Muntañola Torberg. And the workshop will be in a topic of artificial intelligence, which you can understand from the title as well. So augmented reality, virtual reality workshop under the name Agency Across Realities, the Philosophy, Science, and Implementation of the Virtual Worlds will be given by Andrea Ioncoggiocaru from the Numena. Andrea is a CEO and co-founder of the Numena, an interdisciplinary award-winning creative studio designing and program spatial experience. And digital fabrication workshop under the name Biological Patterns of the Design and Fabrication of Shell Structures will be given by Efinia Giannapoulou, that for sure I did not pronounce well. So unfortunately, none of these three instructors are today with us, but we are looking forward to and I encourage you to check the webpage of the Digital Future World to get more information about the workshop I just mentioned. So I would like to thank the presenters from my session and from the session of my colleagues, and see you this summer.
Yeah. Okay, thank you so much, Lemila, Ipsita, Chao, and of course all the instructors, and thank you those who stayed up till the end for the last presentations. Dragos, thank you so much for your presentation, and we move forward to the next session in another 15 minutes again on YouTube live, and see you all on 26th. Bye-bye.
Bye-bye. Thank you.
Bye.